Today we will discuss about beta distribution. Beta distribution. This is also an important probability distribution. So we define this distribution. So this is also the part of continuous probability distribution. This is also a continuous probability distribution. Now we define the distribution as let x be a continuous random variable. Continuous random variable is said to have a probability density function of beta distribution So we define this beta distribution in two parts. That is first kind and second distribution is second kind. So beta distribution of first kind, which is denoted as beta 1. Denoted as beta 1. We use this symbol to denote this distribution. So beta 1. So now we write down the PDF of beta distribution, which is fx. Fx is equal to 1 upon beta mn, but 1 upon beta mn, x raised to the power m minus 1 into 1 minus x raised to the power n minus 1. So this function is defined when random variable x lie between 0 to 1 and m and n both are positive. Otherwise, the value of the function is 0. So when x follow the beta distribution, so we can write down x follow the beta distribution. This is beta distribution of first kind. We denote as beta 1 into mn. So x follow the beta 1 into mn. Beta 1 means beta distribution of first kind. So beta distribution of first kind we denoted by beta 1. So this is denoted by beta 1. अब जो बीटा डिस्ट्रीब्यूशन है इस बीटा डिस्ट्रीब्यूशन को एक्सप्लेन करने के लिए जैसे हमने गामा डिस्ट्रीब्यूशन एक्सप्लेन किया सिमिलरली बीटा डिस्ट्रीब्यूशन तो बीटा डिस्ट्रीब्यूशन भी बेस्ड है किस पर बीटा फंक्शन पर तो वी नो बेसिक डेफिनेशंस ऑफ बीटा फंक्शन So we heard the definition of beta function. So we can say that beta mn. So beta mn is equal to integration 0 to 1 x raised to the power m minus 1 and 1 minus x raised to the power n minus 1 into dx. So this is the definition of beta function. So beta function we defined as beta mn is equal to integral 0 to 1 x raised to the power m minus 1 and 1 minus x raised to the power n minus 1 into dx. अब इसी के साथ में ये रिलेशन भी है कि अगर आप बीटा एम एन लिख रहे हैं तो बीटा एम एन वी हैव प्रूव्ड दैट विच इज इक्वल टू बीटा एन एम सो बीटा एम एन की वैल्यू होती है बीटा एन एम के इक्वल नाउ when beta mn equal to beta nm so we have lots of relations related to beta function and also we have the relation between beta and gamma so we can elaborate this thing that means when we are going to use this definition that means given definition this one so this definition used in the beta distribution of first kind as we have write the PDF of beta distribution of first kind so this definition is used for beta distribution of first kind तो इस ये हमने यूज की है फर्स्ट काइंड की डेफिनेशन के लिए अब बात आती है रिलेशन के लिए तो व्हाट इज द रिलेशन रिलेशन बिटवीन beta and gamma function beta and gamma function so what is the relation between beta and gamma function so the relation between beta and gamma function is beta mn is equal to gamma m gamma n upon gamma m plus n. So when we know the value of m and n, so we can obtain the value of beta mn by using these relation. Now, when we talk about the relation, so this is the relation between beta and gamma. So we will use this relation. And now when we talk about the other definition of beta, so when we talk about the second definition of beta, this definition we can write down as beta mn is equal to integration 0 to infinity x raised to the power m minus 1 upon 1 minus x raised to the power m plus n into dx. So this is the second form. That means we prove that beta mn equal to this. So this definition basically we will use for beta distribution of second kind. So this definition we will use for beta distribution of second kind. So beta distribution of second kind. So you have to clear beta we define for two form. One is first kind or second is second kind. Now, after writing the PDF of beta 1 मतलब first kind की PDF लिखने के बाद, so we will move to the uses. So what are the uses of this distribution, where we use this distribution? So we write down that it is a widely used distribution, widely used distribution in our daily life, in our daily life or day-to-day life. We can say that, or day-to-day life. So now, what are the examples for day-to-day life where we use this distribution? तो आपको ध्यान रखना है कि कहाँ कहाँ हम इस डिस्ट्रीब्यूशन का यूज कर रहे हैं. सो फर्स्ट वी हैव write down that we can use it to model the probabilities. So we make the models, the probabilities. Now, first use. First use the click through rate of your advertisement. Rate of your advertisement. तो जितने भी एडवर्टाइजमेंट्स आप टीवी पे देखते हैं, एफएम पे देखते हैं, उनका क्या रेट है, पर मिनट कितना है, 10 सेकंड का कितना चार्ज करना है, क्या करना है, तो वी कैन ऑब्टेन बाय यूजिंग दिस डिस्ट्रीब्यूशन. तो इसकी हेल्प से हम वी कैन इजीली कैलकुलेट. दैट मीन्स 10 सेकंड का ऐड है तो 10 सेकंड के ऐड के लिए कितना पेमेंट होगा, 20 सेकंड है, सो दैट मीन्स वी कैन कैलकुलेट. सेकंड, द conversion rate of customers of actually purchasing on the particular website. अब जैसे आपने वेबसाइट देखी, अमेजोन हो गया, फ्लिपकार्ट हो गया, तो अमेजन और फ्लिपकार्ट पे एक तो विंडो शॉपिंग होती है. विंडो शॉपिंग में जस्ट हमने देखा और वी लॉग आउट और वी लीव देम. सो नाउ वी हैव टू चेक दैट सपोज अगर 1 घंटे का हमने रेशियो निकाला, 1 घंटे में 50,000 पर्सनस ने व्यू किया, विजिट किया वेबसाइट को, और उस 50,000 पर्सनस में उसका जो कन्वर्जन रेशियो रहा वो क्या रहा. तो वी कैन कैलकुलेट द कन्वर्जन रेट. दैट मीन 50,000 में से एटलीस्ट 1,000 तो ऐसे होंगे जिन्होंने कुछ ना कुछ समथिंग भी परचेजिंग की होगी. ओके, सो दिस कैन बी कैलकुलेटेड बाय यूजिंग this beta distribution. Now, third one, how likely it is that means any leader, suppose or any particular team, we are talking about the Indian team, and this is for cricket team, Indian team will win the Champions Trophy. So what are the chances? So we can predict, that means with this, we can talk about any particular leader. The particular leader will win the election. So what are the chances? So we can calculate by using beta distribution. So now the fourth important thing is that, so the 5 year survival time for a woman with a particular, that means that is breast cancer, and so on. So we can check the time period or calculate the time period. So there are day-to-day life examples. So we have written here. So now, when we see the PDF of this distribution, so PDF of this distribution is given as fx is equal to 1 upon beta mn, x raised to the power m minus 1 minus x raised to the power n minus 1. Now, when we take two parameter, that means m and n, so when we put m and n equal to 1, so we remember or we write down the note, so put m is equal to n is equal to 1. So what is the value of fx? So then fx gives us 1 upon beta 1 comma 1, beta 1 comma 1, and this PDF having x raised to the power m minus 1. So x raised to the power m minus 1. So here we write down x raised to the power 1 minus 1 and 1 minus x raised to the power n minus 1. So this gives us 1 upon beta 1 1. So what is the value of beta 1 1? So the value of beta 1 is gamma 1 upon gamma 1 plus 1. So gamma 1 value is 1, 1 into 1 upon gamma 2. Gamma 2 value is also 1. So this gives us 1. बीटा वन वन की वैल्यू क्या होगी, 1 होगी. अब यहाँ पे क्या हो गया, एक्स की रेज टू पावर 0 हो गए और 1 माइनस एक्स की पावर भी क्या हो गई, 0. सो समथिंग रेज टू द पावर 0 इज 1. सो दिस गिव्स अस 1. अब फंक्शन क्या हो गया, कांस्टेंट हो गया, एफ एक्स इक्वल टू 1. तो इन दिस केस फंक्शन एफ एक्स इज इक्वल टू 1. तो व्हेन फंक्शन इज कांस्टेंट, तो कौन सा डिस्ट्रीब्यूशन होता है जहां फंक्शन कांस्टेंट हो जाता है या कांस्टेंट रहता है, वो एक ही डिस्ट्रीब्यूशन होता है जिसका फंक्शन कांस्टेंट होगा, दैट इज द uniform distribution. So this follow the uniform distribution. So this is the, we can say that PDF of uniform distribution. So this is PDF of uniform distribution. PDF of uniform distribution. और यूनिफॉर्म डिस्ट्रीब्यूशन दोनों तरीके के हमने स्टडी किया है, कंटिन्यूअस भी और डिस्क्रीट भी. सो दिस इज द PDF of uniform distribution. So what is the PDF of uniform distribution? You have to remind this. So that means we write down as 1 upon B minus A. So B minus A, so here X lie between A to B, and we write down 0 otherwise. अब यहाँ पे इंटरवल क्या हो गया है, इंटरवल हो गया 0 to 1. So when interval is 0 to 1, so X lie between 0 to 1. So this can be written as 1 minus 0 means 1. So 0 otherwise. So this beta distribution is converted into the form of the uniform distribution when we consider m is equal to n is equal to 1. So by putting the value of m and n equal to 1, so beta tends to the uniform distribution. ओके, अब इसमें एक और नोट हमें ध्यान रखना है। सेकंड नोट क्या होगा हमारा, अगर हम x is a continuous random variable follow beta 1 beta distribution of first kind, so then we can write down this as 1 minus x, 1 minus x follow the beta 1 into nn. Okay, so we can write down this thing. First we write down mn, so then that is nm. Now, after understanding the beta distribution of first kind, we shall move to the next distribution, beta distribution of second kind. So we are going to discuss beta distribution of second kind. फर्स्ट काइंड के लिए हमने बीटा की प्रॉपर डेफिनेशन यूज करी, दैट इज बीटा एम एन इज इक्वल टू इंटीग्रेशन 0 to 1 x raised to the power m minus 1 1 minus x raised to the power n minus 1. Now for this distribution, second kind distribution, so we define a continuous random variable x, a continuous random variable x is said to have a beta distribution of second kind, beta distribution of second kind this is denoted as beta 2. So this is denoted as beta 2. We write down as denoted as beta 2 with same parameters. We have m and n, both are positive, and its PDF is defined as f of x is equal to 1 upon beta mn into x raised to the power m minus 1 upon 1 plus x raised to the power m plus n. So here the value of random variable x lie between 0 to infinity, and m and n both are positive, so 0 otherwise. So first kind finite interval के लिए defined है, second kind infinite, 0 to infinity. So we can say that random variable x follow the beta distribution of second kind. Okay, so when we see that where we can convert beta distribution of second kind into beta distribution of first kind, so we write down this as beta distribution of second kind convert into first kind by using the substitution y equal to 1 upon 1 plus x. So this gives us 1 plus x is equal to 1 upon y. So this is second kind converted into the form of first kind. So by using this substitution. So we can write down this y is equal to 1 upon 1 plus x. Now we talk about the graphs, and we take some plots on the basis of these PDFs. So now, so first we talk about the beta distribution of first kind. Beta distribution of first kind. So beta distribution of first kind, we have the probability density function. This is equal to beta mn x raised to the power m minus 1, 1 minus x raised to the power n minus 1. Okay, so we remember this thing. So we say that both b mn greater than 0 and random variable x lie between 0 to 1. Now, when we are going to draw, so this is our x-axis. Now this is function of x. Here is origin. Now, so we discuss the case first. So here we write down the case first. So when we are discussing the case first, for case first we consider the value m equal to 1 और n equal to 1. So we have already discussed above. तो हमने पहले ही शो कर दिया है कि m equal to 1 और n equal to 1 लेने पर फंक्शन हमें क्या वैल्यू देता है 1. सो एफ एक्स की वैल्यू क्या होती है उस केस में, तो दिस वैल्यू वी कैन राइट नाउ बीटा 1 1 और x रेज टू द पावर 0 और 1 माइनस एक्स रेज टू द पावर भी 0 होती है और जिसकी वैल्यू क्या होती है 1. तो ये क्या होगा, ये कांस्टेंट फंक्शन हो गया. जब कांस्टेंट फंक्शन हो गया तो उसका ग्राफ कैसे जाएगा, तो ग्राफ प्लॉट करने के लिए जैसे हमने कोई इसके ले लिया, हियर इज 1 2 एंड 3, तो एफ एक्स इक्वल टू 1, एफ एक्स इक्वल टू 1 मीन्स पैरेलल टू एक्स एक्सिस लाइन ड्रॉ कर देंगे. सो दिस इज पैरेलल टू एक्स एक्सिस. ओके, सो हियर क्या बीटा 1 1 है और ये क्या वैल्यू दे रहा है हमारा कांस्टेंट फंक्शन हो गया एफ एक्स इक्वल टू 1 1 से. तो ये तो फर्स्ट केस हो गया. अब हम क्या करते हैं, अब इसमें हमने चेंज किया कि अगर पैरामीटर हम चेंज कर रहे हैं तो उसके नेचर पे क्या इफेक्ट जा रहा है. तो चेंज करने पे मतलब हमने क्या किया, m को तो एज इट इज टेकन 1 और n इज इक्वल टू 2. सो व्हेन वी राइट n इक्वल टू 2 देन व्हाट इज द value of fx. So we calculate as 1 comma 2 and x raised to the power m minus 1 means 1 minus 1 0 and 1 minus x raised to the power n minus 1. So beta oh, 1 2, what is the value of beta 1 2? So यहाँ पर हम beta 1 2 calculate कर लेंगे. So this can give gamma 1 gamma 2 upon gamma 1 plus 2. तो गामा 1 की वैल्यू भी 1 होती है, गामा 2 भी 1 होता है और गामा 3 क्या हो जाता है, फैक्टोरियल 2 हो जाता है. यहाँ से क्या वैल्यू आ जाएगी 1/2 आ जाएगी. तो इसकी वैल्यू तो ये 1/2 हो गई. यहाँ पर एक्स की पावर 0 1 हो गया और ये कितना हो गया 1 माइनस एक्स. तो 1 माइनस एक्स हो गया. तो ये हो गया एफ एक्स इक्वल टू दिस. So when we draw the graph for this, so this gives us fx equal to y. So this can be, we can consider as fx is equal to y. So this can be written as 2y equal to 1 minus x. So that means x plus 2y equal to 1. Basically जो equation of line हो जाएगा x plus 2y equal to 1. So when x equal to 0, so we can calculate the value of y, or y equal to 0, we can calculate the value of x. So now, so when we have a beta 1 2, so beta 1 2, so this we can consider as the value of this we can write down as from the decreasing side. So this side, so here we consider as beta 1 comma 2. So this value is decreasing. This value is decreasing. Now when you put the value of m and n, so now we consider as put m is equal to 2, m equal to 2 or n equal to 1. So function gives us 1 upon beta 2 1 into x raised to the power 2 minus 1 or 1 minus x raised to the power 1 minus 1. So beta 2 1 इसकी value was same. So this gives us 1 upon beta 2 1 into x. So function y equal to x, or y equal to x, we move from the 45 degree from origin. So this we can draw the. So this is for beta 2 1. So this is for beta 2 comma 1. So this is the increasing graph. So we take the examples related to that. Now we move to the next cases. So when m and n both are greater than 1. So m and n both are greater than 1. So then what is the position of graphs? So this is our fx. Here is origin x. So when we draw the first graph, so first graph that is in this way, second graph we draw in this way, and the third graph we write down in this way. So here we have a beta 28 for this graph, we have beta 55 for this graph, and here we have beta 82. So beta 82. So this is this graph is right skewed, not well shaped. So you can draw this, and this is the left skewed when m is greater than n. Here n is greater than n, or beta m looks like as a normal when beta m equal to n. So when we talk about the mn, which mn is less than 1. So suppose we can say that m lie between 0 to 1. So m belongs to 0 1, and n also belongs to 0 1. So m and n belongs to 0 1. So this gives us the U shape. That means approximately the normal distributed curve. So m is equal to zero point 0.5 or n is equal to 0.5. So now we can take one example based on this beta distribution. So we can take the real example. So how likely someone would agree to go on a coffee bar with you, follows the beta distribution, with value of m equal to 2 and n is equal to 8. What is the probability that your success rate will be greater than 50%? Okay, so such type of problem we can solve by using the beta distribution. So success rate is 50%. Greater than 50% means we are going to calculate the probability x greater than 0.5. So when we are going to probability x greater than 0.5, so that means बीटा डिस्ट्रीब्यूशन लिमिट क्या है एक्स रैंडम वेरिएबल की 0 से 1 है. यहाँ पर ग्रेटर देन 0.5, तो इनिशियल लिमिट कहाँ से स्टार्ट होगी 0.5 से, और अपर लिमिट क्या होगी विल बी 1, एंड 1 अपॉन बीटा एम एन. तो बीटा एम 2 हो गया, एन हो गया हमारा 8, एंड एक्स रेज टू द पावर m minus 1, and 1 minus x raised to the power n minus 1. N minus 1 means 8 minus 1 into dx. So this we can write down as 0.5 to 1. So b 1 upon beta to 8. So x into 1 minus x raised to the power 7 into dx. So you try to solve this. The probability will be 0.01953. So means very low. So how to calculate the value of beta to 8? So when we are going to calculate the value of beta to 8, so we use the relation between beta and gamma. So gamma 2, gamma 8 upon gamma 2 plus 8. So gamma 2 value is 1, gamma 8 value is factorial 7 upon gamma 10. Gamma 10 value is factorial 9. So this can be written as 2 into factorial 7. So 9 into 8 into factorial 7. So factorial 7 to factorial 7 cancelled, or 2 for the 8, 1 9 for the 36. So 1 upon 36 is the value of beta to 8. So you can write down this integration as, so zero point 0.5 to 1 upon 36 into x, or 1 minus x raised to the power 7 into dx. Okay, so try to solve this. The answer is this. So the probability is very low. Directly, no one want to visit in Kopua.